And here we have a beginner's problem to get us started off. We're integrating the function d theta times pi over 2 from the boundaries of -1 to -4. So this is basic because the antiderivative of d of theta is theta itself. Then you just plug in you take this out, you pull this out, and you multiply at the end. But you just basically plug in these values for theta, which is really simple math, and then you multiply by pi over 2 to get an answer of 2 pi over 2. Fairly simple. Alright, for the next problem, it tells us to use the areas to evaluate the integral. So we have the equation x dx, and the bound is 2a and a. So when you evaluate this integral and plug in the values, you get this right here, half of 2a minus a times 2a plus a. Once you solve that, you get the area that we evaluated to be 3a squared over 2. Next problem is fairly more complex. The problem itself is an integral from the -5 to 6 of the function I minus x squared over x minus 5 dx. And the first part of the problem says find the points of discontinuity. And since this fraction is over x minus 3, the point of discontinuity will be at 3 because the fraction will be over 0, and that is undefined. And for the next part, part B, you sketch the graph to get an idea of what it looks like, and then go to solve the integration. And this is the integral itself from -5 to 6 of 9 minus x squared over x minus 3 dx. And then you do the integral, you solve, and you get half of 2 times 2 minus half of 9 times 9 times half. And then once you solve for that, you get -7 over 2, which is the area of the graph.